Here we go. Let's do this. We're going to find the inverse. Hold on. What is that? What kind of shape is that? A quadratic parabola. Yes, quadratic equation makes a parabola. Yes, it does. Did we just talk about how the inverse of that is not a function? Okay, remember that. We're going to force this to work. We're going to use f raised to the negative first power. All right, let's do our job. Step 1. Step 2. Step 3, solve for y. Move the 9 over. Look. Remember, I told you it was not a function anytime y is raised to an even power. So there's another red flag, some weird's happening. Let's go ahead and solve for y. Y is squared. What are we going to do? Yes, we are. What else are you going to draw with your pen when you draw a square root symbol? Plus and minus. That's red flag number 2, that you have something that's not a function. So, boom, boom, plus, minus. So, guys, that sideways graph, that's this. That totally 100% makes that. If you plugged it into Desmos, you'd get a sideways parabola, which is not a function. But you need to tell me that you're going to be okay and make it a function. So here's what you get to do. And some kids get ornery and they choose the negative. You can choose the positive root or you can choose the negative root, which means if you chose the positive root, you'd have this right here. If you chose the negative root, it's a negative reflection, it'd be down here. You just can't choose both. So I'm going to say f of negative 1 of x. I get to use function notation as long as that's the only thing I'm dealing with. Ooh, that's a root. So that means you need to restrict the domain. And when you restrict the domain, you just cut that in half, and now they're true inverses of each other. What's the domain for this? What is it? What's the domain for that? Is it going to be, yeah. Is this a bracket or is that a parenthesis? Bracket. That's how you do it. I just started out with the hardest one, by the way. So,
wait, is it negative now or just 9?
It's just 9. Yes. So, you just cut that parabola in half. That's 9 to infinity. And here's your square root. There's your line of reflection. That should go through the order. But you guys get the picture. So that's when the first one gives you something that's not a function. Let me just give you something a little bit easier. So can you please find the inverse of this? Yes, you can, because you just did the warm-up. All right, what are we going to do? We are going to switch x and y. So remember, f of x is the same thing as y, y'all. So x is going to go here. Y plus 6 over y minus 2. That is so ugly because I got to solve for that letter in the denominator. You can't do that. So you got to get rid of the denominator. We're going to multiply both sides by y minus 2. All right, over here on this side, guys, they just cancel, so that kind of cleans up nice. But we're going to have to distribute on this side. So it's going to be x times y, and then x times a negative 2. We're solving for y. You know what to do. Put all your y's on one side. If it doesn't have the letter y, move it to the wrong side. So this is going to go over here, but that negative 2x is getting shoved out the door to the other side. You got your GCF, which is just a y value. I'm going to replace that with f of x after I restrict the domain. And don't forget, when you restrict the domain, you have to take into consideration everything we've done. So we got to figure out what to exclude for that denominator. And that denominator to exclude for that denominator. All right. So using my awesome little inverse function notation here. Domain. All right, here we go. Y'all, oh, it's off my screen. The original problem, that x minus 2, the original denominator, what could x not be up there in the original denominator? What could x not be in the original denominator? 2. Awesome. What can x not be in that denominator? 1. Perfect. So here we go. It's going to be negative infinity to that 1 and 1 to the original, which is a positive 2, and then 2 to infinity. And that's it. Let me pause.